All right. Good morning, everyone. Thank you for joining us for our 3-minute thesis presentations today. I'm excited to host this event this year. This will be an annual event, so we will have that as part of our departmental seminars every year. My name is Sebastian Behrens. I am the Director of Graduate Studies. Took over this summer from Juan, who moderated these events the last years. Before we start, I would like to give a short introduction to what the 3-minute thesis competition is. This is not just something our department come up to, make our busy grad student even more busy. This is something that is part of a bigger university-wide and actually national and international competition. So it starts all here in the room with our 6 contestants today, but it could end up on the world stage representing the United States in an international competition if you make it from here on to the college competition, to the university competition, national, international, and so on. So today we have 6 contestants from almost all our research emphasis areas. And the ones that are not presented, they will know that they are on next year. So I'll count on you because, as I said, this will be an annual event. Now, I have a few slides to just tell you about the 3-minute thesis competition history and how we're gonna do the judging and voting this year. You all will be able to vote in the end. Online audience, as well as you guys here in person. Therefore, you will have to have a phone, laptop, tablet, anything else that connects to the internet ready. Once we go through the 6 presentations, I will display a website link that takes you to a website. You have 1 vote, you pick your favorite presenter, and that will be instantly counted. And then I can look at the results. If Technic works, we should be able to see a graph with the votes, and then we will have a winner. Now, what is the 3-minute thesis presentation? It's a research communication competition that was developed by the University of Queensland in Australia. They started this in 2008. Graduate students have 3 minutes to present a compelling oration of their thesis and its significance. It's not about demonstrating the amount of data or the technicality of your approach, but it's about engaging the audience and demonstrating what impact your research has. It's, on the other hand, not an exercise in dumbing down your research, but it is a challenge for students to learn how to consolidate their ideas so they can be presented concisely to a non-specialist audience. As I said, the University of Queensland held their first 3-minute thesis competition in 2008. And after that, it was adopted by numerous universities and developed into this international competition. You see here a few facts. And I just looked up this morning. I think right now it's more than 900 universities worldwide from 85 countries that participate in this. So we want to see you on that stage representing our department and our university at some point. And we're going to do it as long as it takes to win this thing on the world stage. So today is the start. Now, what are the rules? I sent out the rules to all contestants, but here just for the audience. The contestants get 1 single slide. There's no animations allowed, no gifts, nothing is moving or no animations. No additional electronic media. You cannot play a song. You also have no additional props. You cannot bring something from your lab. You also have just to use your spoken word. You cannot rhyme, poem, rap, or sing your thesis here, although maybe that's something for our annual holiday party, singing your thesis competition. Just, for the grad students, if you want to have another competition of that sort of kind of thing. No, only the spoken word presentations. as I said, spoken, no poems, rap. Yeah, presentations are commenced from the stage, which is this part here. And the contestants know they need to stay between the yellow lines or stay here right on this black tape line. So they are also facing the online audience. I will take my phone and take the time. You have 3 minutes. I will give you a 20-second warning when you have 2 minutes and 40 seconds used, and then you can use these 20 seconds to just wrap it up, because once you go over 3 minutes, you're disqualified. So we are very strict about that. And then the decision is final once the audience has voted. We don't have a panel. We have everyone can vote this year. And for that, you need your, as I mentioned in the beginning, phone, laptop, or tablet. I will give you a website link. You type this in, and then you pick your winner. You have 1 vote. You can change your vote if you clicked on one name accidentally and then wanted to, no, I rather have this. That's fine. It's going to be recorded, but you have just that 1 vote. Now, since everyone is voting, I just thought the last thing I'll do is quickly go over the rules. So, judging criteria. Each criteria has equal weight. The emphasis is on the audience. So first of all, we're looking for comprehension and content. Did the presentation provide a clear background and significance to the research question? Did the presentation clearly describe research strategy, design, and the results finding of the research? And then did the presentation clearly describe the conclusions, outcomes, impact of the research? And then the second part here is the engagement and communication criteria. Was the oration delivered clearly in a language appropriate to a non-specialist audience? Was the PowerPoint slide clear, and did it enhance the presentation? And did the presenter convey enthusiasm of the research and capture and maintain the audience attention? So this is what you are looking for when you pick your favorite presentation. Now, the winner will receive an Amazon gift card sponsored by the department. But since one of us is at the Amazon, so Michael, if you hear us, maybe next year Amazon can sponsor this directly, right? So that would be a good thing. Or if you are out there and feel like you want to sponsor this event, happy to put your name on the screen in the beginning. So the winner will also receive this trophy board. This is legendary. When you have this in your office for 1 year, you are the grad student. You know it. You are special. Previous winners all signed this board. So this is how long we are doing it. 1, 2, 3, 4 names on it. So you will get this prize to display in your office for 1 year, and then you bring it back to me. And you get to sign it in the end, and then we pass it on to next year's winner. Okay. With that, I think I mentioned everything. That the order in which the presenters will be called up on stage has completely been randomized by a computer. And with that, I will step aside. I will get my phone ready. I won't introduce the speakers in any way, just have their name up on the slide. Once they get up and have hooked up their microphones, I will give them the go, and then they have 3 minutes. Audience has unfortunately no questions. So if you have a question for a speaker, keep it. And then afterwards at coffee and pastries, you are able to maybe catch one of the speakers and ask your questions after that. So we will go through these 6 presentations quite quickly then. Okay, so your 3 minutes will start now.
So our lives are highly dependent on weather. And among weather phenomena, precipitation is more important because it's influence our everyday decisions. And as weather patterns are changing as a result of climate change, and as the frequency of the extreme events are increasing, the need to have find a spatial temporal resolution prediction of precipitation becomes more crucial. And these predictions are so important to develop for the development of warning systems and also facilitate the crisis management and reduction of loss to the lives and properties. The history of weather prediction goes back to ancient history. And in this evolving book of weather forecasting, I want to add a story about the role of deep learning and machine learning on the weather forecasting. Today's weather forecastings are done by national weather prediction models. These models, while solving different partial differential equations of dynamic and thermodynamic equations, provide us with a sufficient planet scale prediction up to a few days. But when it comes to providing high resolution prediction for shorter lead times, less than 3 hours, for example, they struggle, the accuracy are not good. And this is mainly because of high computational expenses and also their dependency on initial condition. On the other hand, in the last decade, we have been provided with a huge amount of data recorded by satellites. One of these satellites go over the globe. One of these satellite data is precipitation maps. IMERGE, which provides us precipitation maps every 30 minutes. But the latency is 4 hours, so we cannot use these data directly for our purpose. But we can benefit from these data to train a machine that can actually beat NWPs. So, and that's what I did by developing this network called Angelo. This network takes 12 sequences of precipitation and also wind velocity as the input and provide us with the prediction 8 steps ahead of precipitation. And as you can see, the results actually make sense. So the top one is the observed value of precipitation at the lead times equal to 1 hour, and the bottom one is predicted value, the output of the Angelo model. And the results actually good. And when I compare the performance in different lead times in that final graph, we can see that the lead time is below 3.5 hours. We can actually outperform models. And this shows us that there is a potential to use this model and reduce the cost of natural disaster caused by intense precipitation and flooding. Thank you.
Okay. So halogenated organic contaminants are integral components of many household, industrial, and agricultural processes and products, and they are an environmental concern because they are toxic and they pose a bioaccumulation potential and are recalcitrant to degradation. So biochar is a carbon material that is similar to activated carbon and is produced through a thermochemical decomposition process known as pyrolysis. And biochar has adsorbent properties. It can adsorb various inorganic and organic compounds to its surface, and it has complex electrochemical properties that allow it to mediate redox transformations at its surface. So it can redox transform organic and inorganic compounds. Additionally, bacteria that interface with biochar can exchange electrons with biochar to support their own metabolic processes. And so several recent studies have used biochar and applied it in the environment to successfully remediate organohalogen contamination. Although none of these studies have so far investigated the use of biochar in activated sludge wastewater treatment systems for the degradation of these trace contaminants. And this is important because wastewater treatment systems are often a point source of contaminant release into the environment. So for my experimental work, I am operating sequencing batch reactors for modeling wastewater treatment in the lab, and these are amended with biochar. And so while my long-term goal is to study the degradation of organohalogens in these systems, I first need to characterize how biochar may or may not affect the regular nutrient removal processes that are required for the successful operation of wastewater treatment plants in real life. And I do have some interesting preliminary data on this front showing that biochar may enhance nitrification, which is the first step in biological nitrogen removal. Additionally, qPCR quantification of bacteria indicates that nitrifying organisms, nitrifying bacteria may preferentially colonize on biochar surface compared to the surrounding sludge. And so while I do have a lot of validation of these results to perform, my next step will be to amend these reactors with various organohalogens and study their degradation. And for this, I hypothesize that biochar will stimulate the enhanced degradation of organohalides in activated sludge wastewater treatment systems as compared to controls.
Are you ready?
Just a second. Yeah.
And your 3 minutes start now.
Do you all remember doing this experiment in your childhood where you take a coin and put it in a glass filled with water and suddenly the coin seems to be floating, but in reality, it's still at the bottom of the glass. So what is happening there? It is a phenomenon called refraction, which is tricking our eyes in believing that. This same phenomenon happens to this SMAP satellite, which when it tries to observe soil moisture in the presence of snow. So let me take a step back and introduce you all to this satellite. This satellite was launched in 2015 by NASA to monitor soil moisture and vegetation information across the globe. Since then, this satellite has played a major role in observing and helping in solving many environmental problems, such as weather forecasters can predict flash floods, farmers can grow more crops, and However, at present, this satellite cannot observe soil moisture in the presence of snow cover because snow distorts the signal coming from the vegetation and soil in a very similar fashion as water distorts the signal coming from the coin. So more specifically, if we ignore the effects of snow on the retrieving values of soil moisture, we are prone to underestimate it by almost 30%. So that is why right now there is no current algorithm which could actually estimate these informations in the presence of snow cover. And that is why we get the incomplete information of soil moisture and vegetation from the satellite. And that is where my research comes into play. So we developed, we try to understand how exactly does the snow cover affect these signals. And we made the first ever emission model to model these emissions coming from soil and vegetation and how it affects the signals observed by the satellite. The schematic figure shows on the slide shows the three main components of a developed emission model. So using this, and it turns out that using this model, we can actually predict the information of soil moisture and vegetation with an accuracy of 0.06 meter cube per meter cube, which is as good of an accuracy as observing soil moisture without snow cover. So this availability of data reduces the gap between the of soil moisture observations, especially in the northern hemisphere, where we are prone to underestimate these values where for almost 30% of the time these values are not available. And this product helps researchers and scientists across the world to actually understand how soil moisture is variable below the snowpack, to give us more predictive understanding of snowmelt water filtration and runoff, and inspire scientists and researchers across the world to study global climate change in a better way. Thank you.
And your 3 minutes start now.
Hi, everyone. I think everyone knows bacteria, but do you know how they live? Do they live separately or they live together? Well, in nature, most bacteria, they don't live separately. They will live together as a film-like structure called biofilms. And biofilms can be found everywhere. For example, do you ever notice there are some stains on the surface of your water bottles? And that's biofilms. Biofilms can also be found in water pipes and our human bodies. Now, biofilms are a really hot topic now and have been studied by many microbiologists. However, for me, as a civil engineer student who knows fluid mechanics, my research is about using my fluid mechanics knowledge to better understand the biofilm growth from another perspective. So back to a water bottle example, you may always want to know why it's so difficult to clean your bottle surface. One reason is that after a long time of use, your bottle surface will have some roughness. So the rough surface should have some effects on the biofilm growth. But how much? That's a question we need to figure out. So to solve this problem, we built out this powerful visualization system. It mainly consists of a microscope, a pump, and a macro channel. The macro channel is a very, very small channel. Its depth is equal to the diameter of our hair. We grow bacteria in this channel and to design some patterns to represent the rough surface to see how the rough surface affects the biofilm growth. For now, we find that the rough surface can provide shelter for bacteria to form, to let the bacteria to form thicker biofilms and increasing the biofilm resistance by 3 times. This is a very exciting result, which means maybe next time you clean your water bottles, try to use hair flow rate, but not too high. 3 times hair is enough. At least we have to save some water. Thank you.
Your 3 minutes start now.
Oh, hi, everyone. My name is Jian. I'm a third-year PhD student in transportation engineering, working with Professor Raphael. So my topic for today is integrating humans into resilient next-generation transportation systems. There are 2 parts in my research. The first part is about human and infrastructure. For example, we studied the interaction between human and vehicle at unsignalized intersections. There are 2 outcomes. The first one is pedestrian will yield to the vehicle, or the vehicle will yield to the pedestrian. We have installed cameras and collected data from 18 different locations across Minnesota. We have identified factors and studied the factors that can help increase the vehicle's yielding probability. So the result from my research can help to modify current infrastructure and design new intersections in the future. But there are not only human and infrastructure in the transportation systems. There are vehicles and even automated vehicles in today's traffic flow systems. Of course, here I mean low-level automated vehicles with some driver assistant features. So, they are so-called adaptive cruise control vehicles. It's kind of level 1 automated vehicles. They can navigate the transportation system together with the human drivers. So I am studying the complex relationship between ACC vehicles and the human driven vehicles. It makes the traffic. My research shows the driving behavior of both ACC vehicles and human driven vehicles can be well studied by deep learning. There are good things about automation, but still it provides opportunities for malicious actors to compromise the traffic. So the figure in the right shows the vehicle's trajectory of normal traffic and attacked traffic. So so you can see it's very, very different. I'm currently working on evaluating the impacts of cyber attacks on automated vehicles and developing defensive strategies, such as detection using deep neural networks. In summary, there are 3 components of my research: infrastructure, human, and the vehicle. My goal is to use the learned knowledge to enable next generation control for transportation cyber physical systems with human in the loop. Thank you.
Yeah. Okay. And your 3 minutes will start now.
Good morning, ladies and gentlemen. 3 years ago, the world has been struck by a pandemic that shook the entire world. It affected our lives personally, and it brought devastation to our economics, to the people we love. So today I would like to share with you not only my research, but also the backbone of the very research. How did we go by the research? The first step is the problem, coronavirus, and the spike protein that attaches to our human bodies that facilitate the infection. And we wanted to use that to fight against it. Moving on, we wanted to integrate nature. Perhaps this is the most profound thing about my project, is that we used the vast and extremely intelligent machinery of nature, where we integrated a tree called Moringa oleifera into our project. The tree holds proteins that are extremely cationic, and from there, we wanted to use that for our own research. Moving on, we finally did the research. We wanted to create a membrane that could filter viruses, particularly on cotton material. A vast majority of people do not have access to these high-end surgical masks. So if we can facilitate, or if we can increase the filtration efficiency of those materials, it will be tremendous. So we coated the fabrics with those proteins to create an electrostatic shield, if you will. that enables us to filter those viruses by facilitating the spike proteins in the virus. Finally, this is the most interesting part of research, at least to me, is the implementation. An estimated number of 1.7 billion people around the world at the height of the pandemic were using common fabrics, such as cotton or polyester. Our ability to improve on that, to make the lives of those many people better, there's just simply nothing better or nothing more compelling to fight towards. Thank you.
Thank you so much. These were our 6 presenters this year. So please, another round of applause for all that participated this year. Really appreciate your time and effort. Although this is just one slide in 3 minutes, I know it's taking way longer to prepare. And I appreciate that you took that time out of your busy schedule to join this competition. I also like to thank the faculty who allowed the students to come in, to step into this arena and battle it out today. Now, the next step will be the voting and view the results. Oh, we have a clear winner. I will announce the winner now. Fireworks. Our winner of the 2022 3-minute thesis competition and the winner of this trophy board plus another gift card is Ivani. Ryane, you will be the runner-up, so you will also present us at the college competition on October 20th. So, and of course, I'll see you all again next year for the same competition. Thank you so much.